Hey everyone, and welcome. I am absolutely thrilled you're joining me today because, well, we're embarking on what I like to call a mathematical hero's journey. Today's explainer is basically your definitive guide to mastering everything you need to know about direct and inverse proportions. And look, this isn't just about memorizing some boring formulas. It's about unlocking a genuine superpower that lets you turn those wordy, confusing chapter problems into simple, everyday arithmetic. We're going to build your fundamentals so strongly today that by the time we wrap up, you'll be conquering these concepts with absolute confidence. Let's get to it.
To prime your brain for the journey ahead, I want you to ponder a little puzzle. Imagine this. If 5 workers take 12 days to complete a job, how many days is it going to take 8 workers? This is a classic real-world scenario pulled straight from the SAT's prep materials. Just think about the logic for a second. Would more workers take more time or less time? Hold on to your answer because we are actually going to crack this exact problem together before we finish up today.
Okay, let's dive into our roadmap. Today we're covering 1. What is proportionality? 2. Direct proportion unpacked. 3. Inverse proportion unpacked. 4. Solving word problems. And finally, 5. Common mistakes to avoid.
Section 1. What is proportionality? Let's start right in the ordinary world of everyday math concepts.
Before we solve anything, we really need to understand how different quantities relate to each other. By definition, a proportionality relationship happens when two quantities are related multiplicatively by a fixed number. Now, the absolute key word here is multiplicatively. We aren't just adding or subtracting some random amount, right? It's a rigid mathematical bond where the numbers scale together based on a constant multiplier. Section 2, Direct Proportion Unpacked. Now that we've got the basics down, it's time to explore the first of our 2 major concepts. So, direct proportion is actually incredibly intuitive. Basically, as one value increases, the other increases at the exact same rate. And conversely, if one decreases, the other goes down too. If we say y is directly proportional to x, the formula is y equals k times x. You'll definitely want to mentally highlight this formula. That k right there, that's our hero. It's the constant of proportionality, meaning it's the fixed ratio between our 2 variables. Now, what's really interesting about this is how perfectly it visualizes that constant k. Take this example straight from a Class 8 worksheet. If 4 kilograms of potatoes cost 60 rupees, dividing that cost by the quantity gives us a ratio of 15. Now, if we buy 12 kilograms, the cost jumps up to 180 rupees. But note that final piece of data. 180 divided by 12, it's still 15. The quantities changed, sure, but the ratio, our constant k, stayed exactly the same. Here's another brilliant everyday application. This one from the NCERT solutions. Imagine you're mixing paint. To get a very specific shade, you mix 1 part of red pigment with 8 parts of the base. Well, if you need a bigger batch and decide to use 4 parts of red pigment, you have to maintain that direct proportion. Since you multiplied the red by 4, you literally have to multiply the base by 4 as well, giving you 32 parts of base. See? They scale up together flawlessly. Section 3, Inverse Proportion Unpacked. Having mastered that first path, we're going to shift gears completely and look at its mirror image. In an inverse proportion, the 2 quantities move in opposite directions. As one increases, the other decreases proportionally. And because of this opposite movement, our formula changes a bit. It is no longer division that gives us our constant, it's multiplication. Here, x multiplied by y equals k. So the product of the 2 variables is what creates that constant k. Let's think about a car journey. This is a great example found in the NCERT materials. Say you're driving somewhere at 60 kilometers per hour and it takes you 2 hours. If you speed up to 80 kilometers per hour, your travel time drops to 1.5 hours, right? Speed goes up, time goes down. But watch what happens when we multiply them. 60 times 2 is 120. 80 times 1.5 is also 120. In an inverse proportion, the product is always your constant. Let's just put them side by side to really build a clear picture in your mind. This is the ultimate showdown. Direct proportion, both go up together, and you find the constant by dividing. Inverse proportion, one goes up while the other goes down, and you find the constant by multiplying. I highly recommend burning this side-by-side comparison into your memory. It's going to save you so much time on exams. Section 4, Solving Word Problems. We are now entering the trials phase of our journey, where we actually put these tools to the test. The experts over at Third Space Learning provide this really fantastic, foolproof 4-step guide for this. When you're faced with a word problem, don't panic. First, determine if it's direct or inverse and write down the corresponding formula. Second,
use the complete set of data they gave you to find your k value. Third, substitute that k and your other known value into a new equation. And finally, step 4, simply solve for the unknown. It is a beautifully logical process.
Now, the hardest part for most students is honestly step 1, just figuring out which relationship applies. So the crucial point is to use logic before you use math. Think about these clues. Buying pens or cloth. More items mean a higher cost. That's direct. People doing a job like workers building a wall. Well, more hands make lighter work, meaning less time. So that's inverse. Driving a car. More distance requires more petrol, which is direct. But going at a higher speed means it takes less time to arrive, which is inverse. Make sense? Section 5. Common mistakes to avoid. Now we have to face the villains of our chapter.
These are the traps, the common misconceptions that consistently steal marks away from students on test day. The first villain is what I call the additive trap. Third Space Learning warns that when students look at a table of values, they might notice that x went up by 3 and mistakenly assume they just need to add 3 to y to find the next number. Guys, this is a fatal error for this chapter.
Let me firmly correct this right now. Proportions require a multiplicative relationship. You cannot just add or subtract values to find the answer. You absolutely have to figure out what number is being used to multiply or divide. Always, always seek out that constant multiplier k. If you're adding, you're not doing proportional math. This second major villain actually brings us all the way back to that hook from the very beginning of our explainer. The SAT Prep Guide highlights this classic trap. A student sees 5 workers take 12 days and 8 workers take X days. They immediately set it up as a fraction. 5 over 12 equals 8 over X. They cross-multiply and boom, they get 19.2 days. But wait. Think about the real-world logic for a second. If you add more workers to a job, how could it possibly take more time? And this brilliantly illustrates why identifying the relationship first is absolutely critical. Workers and days are in inverse proportion. The formula isn't division, it's multiplication. 5 workers times 12 days equals our constant, which is 60. So 8 workers times X days must also equal 60. 60 divided by 8 gives us the true correct answer, 7.5 days. By just slowing down and thinking logically about the scenario, you easily sidestep a trap that catches thousands of students every year. As we wrap up today's explainer, I want to leave you with one final provocative challenge from a Class 8 worksheet just to test out your new superpowers. If 1,000 students in a hostel have enough food for 28 days, and 125 students shift to another hostel, how many days is the food going to last now? Ask yourself, is this direct or inverse? How many students are actually left? I challenge you to set up the equation and solve it. You have all the tools you need now to easily understand all the concepts of this chapter. Keep practicing, stay curious, and thank you so much for learning with me today.